Hi, I'm Ruiho. This is my project, the prediction for bike sharing systems. For the problem definition, in modern society, bike sharing systems are gradually in the place of traditional bike rentals due to their automatic process from membership, rental, and return back. Through the automatic systems, it's more convenient for users to rent a bike from a particular position and return back at another position. However, it's a big challenge to manage the allocation and number of bicycles. Many factors can contribute to the number of rentals, and such as weather conditions, temperature, day of week, etc. So the aim of my project is to find out relationships between the number of bike rentals and the environmental settings and to predict the bike rentals based on these factors. Then for the data, for the first dataset, the bike rental count dataset is for year 2016 and year 2017 from the capital bike sharing systems. For the second dataset, the environment factors dataset for DC from 2016 to 2017, there are 5 factors. Weather situation, there are 4 different values. One means partly cloudy or few clouds. Two means misty. Three means light snow or light rain. Four means heavy rain and ice pellets. The temperature, the range is divided between 0.02 and 1. The day of week, there are 7 values for different days in a week. For the data preparation, since the initial data format is not data analysis tool friendly, so I combined the 2 files together and convert it into the CSV format. Finally, I use the function string to date time to parse the strings time column in the CSV files and convert them into specified date and time cells, which can be interpreted by the following notes. And for the models, in KNIME and Weka, I use 4 different models. Regression tree model is for classification. The decision tree model is also for classification. And the k-means model is for clustering. And finally is the correlation matrix. In KNIME, for the regression tree model is here. For the variables weather situation, temperature, humidity, and wind speed, I configure the node simple regression tree learner to find out the underlying relationships. And for the weather situation, there are 4 categories. From the result, this is the scatter plot. So the conclusion is that the less cloudy or less rainy the weather is, the more bike rentals are. And for the temperature, the density of the figure just means the frequency of the relative weather conditions, which does not mean the number of bike rentals. So I can see that when the temperature is between 0.65 and 0.8, the number of rentals is larger. And for the humidity, when the humidity is between 0.25 and 0.6, the number of bike rentals is larger. For the wind speed, I can see that the smaller the wind speed is, the larger the number of bike rentals is. Finally, I use the XPartitioner to get training data and test data and then configure the node simple regression tree predictor and XAggregator. Here is the prediction result. And for the variable quarter, since there is no known data about the quarter, I'm going to extract the needed time parameter quarter from the converted field with the data field extractor and then analyze the target variable count. This is the quarter. And for the results, there are 4 categories, and different categories represent each quarter. It can be concluded that the reliable quarter does not have too much influence on the number of bike rentals. And finally, for the reliable day of week, there are many repeats in the CSV file. So after extracting the day of week, I calculate the mean value of rental counts related to the day of week through the group by to achieve the manual aggregation. And for the result, I can see that the number of rentals is relatively small on Sunday. And for the another model, the decision tree model, and since only nominal attributes are allowed for the target variable, there needs another step called the number to string to convert the numbers to strings. So here I only test the day of week. You can see that the number of bike rentals is relatively small on Sunday. And for the third model, the k-means model, it aims to partition and observations into k clusters, in which each observation belongs to the cluster with the nearest mean, serving as a prototype of the cluster. This results in a partitioning of the data space into Voronoi cells. And for the variable weather situation, the temperature, the humidity, the wind speed, the quarter, the day of week, I can see that the results are or similar to the results in the regression tree model. And for the correlation matrix, it's used to calculate the correlation coefficient for the pair of selected variables. The coefficient is in the range from -1 to +1. -1 means 100% negative association, while the +1 means 100 position association. So from the matrix, I can conclude that the temperature has the most degree of influence on counts. Then is wind speed and quarter. The weather situation and humidity has relatively less influence on the count of bike rentals. The day of week nearly has no influence on the rental count. And in the VECA, from above 4 different models in 9, although there exist some nuances, it's true that the temperature and wind speed have great influence on bike rentals. So here I use the Weka and use the k-mean models again to verify it. For variable wind speed, the k is equal to 5. For variable temperature, k is equal to 15. The two results are similar to the results in the 9. So finally, for what I have learned with the 4 different models, it can be concluded that the environmental factors, temperature, and wind speed have most of influence on bike rentals. The smaller wind speed is, the more bike rentals are. When the temperature is between 0.65 and 0.8, there are more bike rentals. The count of bike rentals have been predicted in the previous page. Secondly, it's very important to focus on the objectives and know what's going to do to avoid digress from the point. Thirdly, the data preparation is really important. Some tools can only handle the data with a specified format. Now, for the problems I have faced, the data analysis tools have quirks since there can be limitations for the input data. Secondly, in the dataset, there is some redundancy or some data is not needed. So for the first problem, to use some special nodes, I learned how to convert my data into acceptable formats. For the second problem, I used the data field extractor from the time series to extract the needed data. Besides, I calculated the mean value to achieve the manual aggregation. This is my what my project about. Thank you for listening.